everyone, welcome back. Now so far we have created our model, we've used a linear equation, and then we have made some predictions using two different methods, a simple and a slightly more complicated method. But the next question we need to ask ourselves is, how good is this linear model? There's a couple of ways we can look at that. We can look here at this r squared value, the coefficient of determination, 0.97. Now that's fairly high. This value of r squared ranges typically between 0 and positive 1. The closer it is to positive 1, the stronger our evidence is that we have a good model. But this is not the only way to look at a model. We can use a thing called residuals. Now to do this, we're going to go up to our Data tab, and we're going to use that data analysis package that we installed earlier. When I do this, there's a lot of different choices. The one I'm needing is here, regression. So I'll say OK to that. Now, this asks me, what are the y values that you're working with? That was these percentages. And then what are the x values? These are the years. Now, at this point, the one thing that I do want to tick here is residual plot. More about that in a moment. And I'll press OK. This appears in a new worksheet. So there's my original. Sheet number 2 is the new one. And there's a lot of statistical information here. The parts that we're focused on, we would recognize this number here, r squared. That was on our previous graph, 0.97. But we've got a little bit more detail here. If I click on that cell, you can see there's a lot more decimal places here on this value. We would also recognize these numbers here. So the intercept, 498, we use that. And it says x variable, but it means the gradient, and negative 0.214. Now again, if I click on the individual cells, there are a lot more decimal places available here for us to work with. I'll come back to that in a moment. The most important part, as far as I'm concerned, is this residual plot. Now I'm going to click on this, copy it, and then go back and put it on my first page. And I want to zoom out a little bit. Might reduce that, and then I'm going to compare this underneath my original graph. Sorry, too far. Now this residual plot tells me a lot about the quality of my model. Residuals are the difference between the predicted value and the measured value. So let's look, for instance, at this data point here. The measured value was where the x is, 66. The predicted value is where the line goes through here, which is somewhere around about 65.9 perhaps. There is a difference between them. The observation is higher than the prediction. That residual point there, with a value of about 0.1, that residual point represents that difference between the measurement and the prediction. This one here, the prediction and the measurement are almost exactly on top of each other. That residual point there represents the difference between them. It's almost 0. So that's great. We want all of our predictions to be this good. This one here, the residual is slightly positive, not as much as the previous. This residual, the measured value is a bit below the trend line, so the residual is negative. This one's even further below the trend line. The residual is more negative, and the one over this side is really far below, so it's even more negative still. Now this pattern of residuals is not good. These residuals are forming a curved shape. You can see it clearly goes upwards, peaks, and then starts to come back downwards again. Curves or wavy shaped residual plots are not a good sign. It means that our linear model is probably not the best choice for this set of data. So when we try to judge the quality of the data, we do two things. We look at the value of r squared. The closer that is to 1, the better. I'm also encouraged by the fact that my linear model, the trend line or the predictions were actually cutting through each of the error bars, only just on this one and only just on this one, but still touching the error bars. So that's encouraging that my predictions were within the uncertainty range, but this is not a good sign. Having a curved shape on a residual plot indicates to me that a linear model is probably not the best choice, that we may have to use some sort of a different mathematical function. Ideally, what would we want on a residual plot? We would want small values of residuals. Well, these are fairly small. They're all about 0.1 or less, but we would want the residuals to be randomly distributed, not a definite curved pattern going on. Right, that's enough for this video. Next time, we'll be looking at how we can create a better model for this data. Thanks for watching.